Okay, so about the project. So basically, you can get your own idea. I have a couple of ideas there. First option of doing the project is to just make the also the PSOC 5 exercises. They are a little bit different, and actually you need different tool set for that one. And then you would need that PSOC board, PSOC 5 board, and you would probably also need to do some wiring there and soldering some connectors. So before soldering anything to those boards, you should check it from Robert Mikalik if it's okay. But anyways, that's actually that board is quite powerful. It has the well, PSOC 5 has the ARM-based processor, ARM Core C0, so it's basic ARM processor and low power and quite good performance processor. So it's actually quite powerful for anything. It also has the computing power there. But the tool set is different. Now we have been using Designer, which is the electronics engineer's approach. It has wires and blocks and even details about how those the blocks are working inside. But the PSOC creator for those kits, PSOC 5 kits, is basically that's more software engineering approach. So it has, say, looks more modern environment, and it also might be confusing after this, the Designer tool. But anyways, that's one option. If you are taking that one, you don't need to send any email to me. Just start doing. Option 2, data acquisition system for Raspberry Pi 3. I have been actually having this one as a constant project topic. Nobody has done it yet. It's you know, there's definitely there is a need for that one. The Raspberry Pi 3 board has the data codec, but well, the audio codec, but it's not the same thing as having a real A2D converter there. And with PSOC 1, you can quite easily make that the data acquisition system co-processor for the Raspberry Pi. But only if you are familiar with Raspberry Pi, basically, if you have used that one and know how to access the port information. The easiest way actually is to just install the Python there, and there you have the access to everything. Okay, but anyways, that's the second option. Then controlling greenhouse. Yesterday I told you, okay, we are in a deep shit. One solution is that we really need to start growing our own stuff closer than, say, the tomatoes are coming from Spain. Doesn't make much sense. Tomatoes you can grow in Finland in summertime. In wintertime, they will be quite expensive. Okay, so that's greenhouse kind of makes sense for your generation and your kids. Option 4, your own topic. And yeah, there are a couple of ideas has been already here. So yeah, those both actually sound feasible. So if you have any hobby, but well, you are students, you don't have any time for hobbies yet. But anyways, if you remember having some hobbies, you know, you might actually combine your hobby with the project. Or if you really need some gadget and want to try to do it yourself, yeah, sure. That's possible. If you are, let's see, how many of you have a car? Nobody? Yes, you have cars. Are you tuning the cars? Not yet. No, yeah, sure. Nobody. How about motorbikes? Anyone have a motorbike? Yes, you have a motorbike. Have you thought about tuning it up a little bit? Not yet. Okay. Yeah. So, well, there you basically just need a processor and access to the CAN bus, and then hack it a little and crack it a little. And yeah, there is actually one good example. Well, it's not a good example. It's an example. A couple of students, Finnish students, about 5 years ago. No, more than 5 years ago. Closer to 10 years ago, actually, when the piece was really new, and they had the Nissan NSX 200, which was a good, real deal back 10 years ago. Which when you take it from shop, it has more than 200 horsepower already. They crank it up a little bit and measured more than 500 on the wheels. A little bit of programming and their own electronics and that kind of stuff there. Okay. So it's, more than 5 years, so the crime is now, it's old crime. Uh, okay, so project, what I'm actually asking you to do is make a nice project. And how to submit? Well, basically you would submit this with the same form as the exercises, but actually write a short report, few pages long report, and I would like to see the demonstration, meaning take a video, post it somewhere. If you have Google account, you also have the YouTube channel. You just have to take it, and start using it, or any other, video repository that you can share your video as a link. No files, a link. Videos are kind of big for sending as an attachment. So I would like to see the demonstration. So basically your documentation should show the demonstration. It should also show the wiring, external wiring if needed. So think of the project report so that a fellow students could replicate whatever you did. So in that accuracy, no more than that. And then the link to the main so that I can say, not even have comments. Comments are in German, and that kind of stuff. Okay. Any questions about the project? Yes. Short description of the project. Yeah. What you are going to do. Few pages. Usually, enough of information so that some of your fellow students here can replicate whatever you did. So, electrical wirings, external electric wirings, what parts did you use, that kind of stuff. And the link, of course, to the project, the zip project files and that kind of stuff. We can basically share each other's email addresses, and then you can check if your report is okay. If the fellow student thinks that he or she can replicate the thing based on the documentation, then it's enough. Yes, you have a question. Only some of these terminals should be there, or actually, if you find this kind of piece of board, then you don't need any soldering, since you can use these pins to attach wires. So, but if you don't find enough of them, then basically it would be either this or the female pin header there. It's not bad actually. It takes only a few minutes to do it, and then more minutes to redo it. Okay, my email address. Oops, let's put that on T. Antti.Piironen at metropolia.fi. So that's my email. Just first name, last name at metropolia.fi. Okay. Any other questions about the project? If I find a good description what should be in the project report, I will just put it there, maybe today. Okay. So next topic would be continuing the yesterday. Okay, I will leave the third topic for the later, say after the lunch break. After the lunch break, I have one extra topic. It's very important. All right, so yesterday we actually went through some of the serial interfaces stuff and went through a bunch of the slides, and the yesterday the fourth exercise topic was about one wire and how to employ the UART. I look at the last year's notes and actually noticed that, well, this here, the USB serial port, or that translator actually has, this is also defined as DTE, data terminal equipment, same as that one, which means that you actually need to connect this one to that port so that you will cross the lines. So to transmit off your PSOC goes to receive off that USB serial port and vice versa. I think, at least that was marked on last year. But well, it's only changing the wires if it's not that way. Okay, but anyways, and then there was also that one 4.7K resistor here, pull-up resistor. Actually, this usually works also without that one, but just in case. It's actually on the PSOC, the documentation to add that external resistor there. Okay. This is strong line drive, so it means no resistors required, just those wires. And remember to connect also the ground, the common ground. Otherwise, you will get lots of noise there. Okay. Then another thing about this UART, maybe I should actually show that one on the PSOC designer. There, and take that. one of those projects. Let's see. Yeah, this project. No, the other one. Sorry. I think it's this one, the last one, where I had the word there. I basically told you about it, but usually if I just tell people things, you forget it in 5 seconds. If I show you things, then you might actually remember it in 1 or 2 hours. If you do it, then you will remember, learn it and remember it forever. Okay. Anyways, some reminders. Now, when we have a communication block here, we really have to take closer care of these frequencies and where these clock rates are coming from. So we already have the easy A to D converter there, which takes actually, those blocks are taking probably input signal from the CPU clock, since it takes 16-bit divider here to get the clock rate correct to your the A to D converter block. Okay, that sounds like it might be actually something to do with that. This takes the that not CPU clock, but the system clock directly and start counting from that one. But we are using actually the counter 8 there is used to provide clock signal for our low pass filter. And that was set to 400 Hertz after that counter. And that was done, or was it 400 Hertz? No, it was higher than 400 Hertz. No, 480 Hertz, something like that. It was from the filter designer. But anyways, there's minor detail. Now we actually have to do the clock rate for the UART. And that should be fixed with better than 5% accuracy. Okay. Fortunately, in this data sheet, actually, we have a way to calculate. At least it used to have it. Let's see. The bit rates. How to set the bit rate for what? It was in the middle of some text here. See, this is clock. Clock, yeah. All right, so there you go. If desired baud rate is 9,600, the clock to the UART should be 8 times of that. So meaning 76.8. And those are the ways you can get it close enough. As you can see, the divider for the 24 megahertz should be 312.5. Okay, we cannot take 0.5 divisors for clock. Actually, we can, but we are not doing it. You can use the double clock, 48, then you can actually have that. Okay, but let's not go that way. Okay, but anyways, 312.5, so it's either 312 or 313, but anyways, both are within 5%. And basically, with these settings, you can do it. And currently our setting is 10, 10, 100 because we wanted that 10 kilohertz, or 20 some kilohertz in here. So we need to fix those, and then basically we need to first take the VC1, 2, 3 and change those so that we can get the correct bit rate, and then fix the frequency for after the counter. So we change the divider. The current divider is the period is 6. Okay, so it's not a big deal. So divider 10, 10, 100. So now we have the divider of 60,000 for the system clock. We need to leave, have that one remaining there, but well, if that one requires, for example, there was a what? Count applicable time. Parameters. There. Okay. I would guess I would go that way. So 2, 4, and 39. 2 and 4 and 39, or 8 and, well, maybe that's 2, 4, 39. There we go. So, and use this one as a clock to the watt. And now we need to basically get this one fixed. So that gave me 300. I don't know if I can do it on that one anymore, basically. Divided by 312. So we need to actually get that. So it's around 200. Yeah, it's okay. So it's about 190 or something like that. Right. 8 bits. We can do it. We got lucky. 8 bits, we can still use that. Okay, 95, something like that. Yeah. So with those numbers, we are still having about the same low-pass filter, and what is fixed with that. Okay, this might actually get a little bit tricky when you add more functions to the system. For example, when you put the SPI. Where'd you get the SPI clock rate? Fortunately, SPI is synchronous. One wire, let's see, I haven't taken a look at the one wire. Okay, one wire actually also requires clock. Clock must be 3 megahertz. Must be. Meaning system clock divided by 8. So basically, if we take system the clock from VC2, we have divisor of 8. So we got lucky. Okay. One wire, otherwise, well, one wire is a fixed bit rate protocol. It has only one correct bit rate. Okay, the UART, or this old-fashioned serial port, asynchronous serial port, there you have basically multiples of 300 hertz or bits per second, or to the power something times 300. Well, actually, to the power of n times 150. Okay, and then fortunately, SPI and I2C bus are synchronous buses. They have clock rates. There you have more flexibility. But this asynchronous data communications, you really have to be careful of fixing the clock rates exactly. Yes, you have a question. Uh, which for one wire divider. All right, let's see. One wire datasheet tells you input clock. It must be 3 megahertz. So divide by 8. We have 24 megahertz system clock, and divide by 8 is on VC2. Yeah, divide by 2 and 4. Yeah, yeah. VC1 is divide by 2 and then divide by 4. That's divide by 8 altogether. Yeah. Okay. Of course, there is always way to go around the problem if that becomes a problem. All of these registers, or even the global, the resources, they are just registers that you can overwrite your software. So if you need to change the clock rate at the middle, you just go and for the communication, for example, you just go and just do the software. But then, of course, you have more and more code, and you have to take, by manually care of that the clock rate is correct when you need it. Okay. So, yes. Mhm. Uh, yep. Yep. Yes, yes, you can do that. Yes, yes, that is okay. We are just running out of blocks here, so it's better first try to use these global resources, fix the global resources, but of course then if you have enough of digital blocks, you just use them. There's no difference there. Functionality, they are still the same. They do the same thing. Okay, so yeah, and basically on the fifth exercise, you will add a couple of devices more. Yeah, I2C, I2C, which has the pull-up resistors and the SCL and SDA lines. Okay, this is actually hardware uh, the system, and actually, well, there are these different type of modules on. Let's see, where's that? Digital communication. I2C, where's I2C? Yes, there's a hardwire version which can be only on couple of different pins. And then there was the another one, easy I2C, which was basically I2C slave, meaning that making this one I2C device. But actually this I2C I2C master is a software only. It does not take any digital resources. because actually the timing is quite simple to arrange, fast or slow enough. You just need to fix the port and pins. There's plenty of flexibility where to put the I2C. But you don't have any flexibility since it's actually fixed on the exercise. But anyways, I2C and then SPI. SPI device. Okay. Chip select. Clock. Master in, slave out. Master out, slave in. Could be that there's only one of those actually on the device. Our device is the A to D converter, MCP 3201. 12-bit SPI AD converter, which basically also requires the external reference, external voltage reference, and I have the I think MCP 1541. That voltage here is 2 to the power of 12 millivolts. So a quite good conversion. So 12-bit A to D converter and 2 to the power 12 millivolts voltage reference. So it means one bit here is 1 millivolt exactly. All right, and then it has the that's the reference input, and then we have the data in, the voltage in. Okay, that's where you put your analog temperature sensor. Wow. So lots of wiring. But it's quite straightforward in any case. You just need to be careful not to put all the wires and stand out thinking about the code. Do it one by one, step by step. If you try to fix everything at the same time, it will never be fixed at all. It'll be like my home projects usually. Never fixed. But anyways, do these piece by piece. I think on the fourth exercise, I would guess that one way would be start from the working third exercise, then try to put that data to PC. Then you have one more debugging channel actually. After that, take and start playing with the one wire and maybe cloning the project since you already got half done when you have the working part. And when you have done the fourth exercise working, then maybe go first try to add the I2C, then the SPI, and at the last point fine tune it with the, let's see, I think I have it. In this exercise, I think I have, yes. On the fourth exercise, it's okay as long as you get the numbers. But in the fifth exercise, the numbers should be in JSON format. And what is JSON? Well, yep. So basically, you just have the parenthesis, then string, the colon value. If you have more than one value, then you add a comma, string, colon value, and so on, and all in ASCII. And I think there are also some examples of what they look like. And some links to how to get things done. See this JSON section. Oh wow, there are actually some code to generate the JSON. And absolutely no guarantees they work in this environment. Well, it's whatever comes from internet. There's the guarantee that they stay for a while there, then they and also what is also guaranteed internet that it doesn't work every day. Okay, good. So any questions about these exercises 4 or 5? I have given you basically the most important hints, I think. Yes. Yes. Yeah. Yep. Yes. Later on, you can get some, not probably help, but more questions from me. Yeah. Well, you have, also local support here, so. Yeah. Yeah, the local support. That's the best local support you can ever have. Your colleagues, your teammates, your friends. Teachers come and go. We do only what we are paid for. So, but with friends, you help each others. All right. So that was the exercise 5 part. So today around 1 o'clock, I will have a very important session for you. 1 o'clock. Be here at 1 o'clock. I'm not saving a video of that special session. It's one time only. Just for you.